Coming up on This Week in Computer Hardware, let's talk E3. The Radeon 5700 and 5700X sound sweet, but AMD's 16-core Ryzen 9 3950X is the big story this week. And let's have a little reality check on 5G, shall we? All that and more coming up next on Twitch.
Netcasts you love.
From people you trust.
This is TWiCH.
This is TWiCH, This Week in Computer Hardware, episode 521, recorded on June 13th, 2019. Did Intel just get stomped by AMD? Welcome to TWiCH, This Week in Computer Hardware, TWiCH weekly show that aims to bring you hardware news, desktop hardware news this week, a little bit of phone news, a little bit of console news, but mostly it's all about desktop hardware. And E3, big old gaming show down in Los Angeles, took place just this week. And the big story is probably... Well, actually, I don't care. The big story that Sebastian and I have been texting each other about is the Ryzen 3000 update that came in the form of some Geekbench results that leaked of the heretofore unknown 3950X 16-core, 32-thread, maximum Zen 2, baby. And I don't generally say baby in a podcast. But today I am saying it. It's a special podcast. Yeah, I do have the peculiar habit from my father of referring to adult men as babe. But that's weird and complicated and not really about hardware at all. What's crazy about this is the benchmarks. And as soon as I saw these, I think I texted you. As soon as I saw these, read them, and then looked at them again like 12 hours later because I just couldn't believe it was true. So Ryzen 9 3950X, man, you want to talk about timing something for impact, right? E3, 9900, whatever. Intel's making noises at the corner of the big gaming show. Look at us. We've got a fast processor. It's only $2,000. It's practically affordable by our standards. And I'm setting this up just to be particularly cruel.
That is cruel. Think of all those nice people at Intel who are going to be hurt by your words.
Some of whom we know personally. But right, so we got Intel's 18-core chip, and so some Geekbench numbers, Geekbench 4 numbers show up, and I'm going to kind of stick closely to the WCCF Tech article, which Hassan Mujtaba wrote, which I highly recommend you go and read in detail because it's an awesome story, and I'm grateful for him to bring it to our attention. But man. So Geekbench 4, AMD Myrtle, that's AMD's internal test platform name, 32 gigabytes of DDR4 running at 4100 megahertz. Quote, the exact clock speeds of the chips are not being reported since the base frequency is mentioned as 3.3 gigahertz and 4.3 gigahertz compared to the final specs of 3.5 gigahertz and 4.7 gigahertz for base boost clocks. So we don't know what the deal is. But we do know that the only AM4 chip with a 16-core, 32-thread configuration is the 3950X. So this is technically running slower than what should be the factory clocks. Look at those numbers there. Single-score number of 5868, multi-core number of 61,072. That sounds fantastic, but benchmarks in a vacuum without comparison are useless. So let's put that into perspective. A Ryzen Threadripper 2950X gets around 4,800 points in single and 38,000 points in multi-core tests on average. So 1,000 points higher in single score, about 20%, and somewhere in the neighborhood of, 35-45% higher in multi-core. The Threadripper has 16 cores, costs $899. The Intel Core i9-9980XE scores around 5,300 points in single, or about 500 points slower than the almost 600 points, between 500 and 600 points slower in single. And the i9-9980XE is 42,000 points in multi-score, or approximately, let's call it 40% slower. It has 18 cores. It is priced at $2,000. So, okay, what does Ryzen's flagship cost? The estimate we're hearing is about $500. So would you rather have 50% faster performance in multi-threaded applications for $500? Or would you rather pay more money for something that was considerably slower? Oh, wait, it was something in the neighborhood of 4 times as much.
And the 3950X, they kept the actual pricing hidden until the final, like, one more thing revealed during their E3 presentation. And
I'm sorry, $749.
$749, yeah. The $499 for the 3900X, and it's $749 for the 3950X.
I apologize. It's only
yeah, I mean,
I don't
it's
know. Let me do some actual
far
math.
less than half as much money. Yes.
Yeah.
A third as much money.
Oops. So how solid are we feeling about these numbers?
The only thing I wonder about is you alluded to the clock speeds, 3.3 and 4.5, I think it was, or was it 3? Yeah. 3.4 and 4.3. The base boost clocks on 3950X are going to be interesting to look at, especially in a workload longer than Geekbench, which runs for a few minutes, because they're hitting a very aggressive TDP with this. That was the most surprising thing to me. I knew they were going to have a 16-core. We've heard rumors about this for a long time. They're putting 2 chiplets on the package, so at some point you'd think they'd both be fully enabled 8-core chiplets. So that being said, it's already been announced. It's not here yet. It doesn't have an official release date. It's just being teased for like September. So at some point before the end of the year, early, mid, late September, we might see these things for sale. And I wonder if part of that is binning, just the process of getting enough of these that can actually perform at that level, because there maybe an early sample is only at 3.3 to 4.3, but the final specs, what they've been able to determine they can get from this thing while hitting this aggressive 105 watt TDP, which is the same TDP as the 3900X, which obviously has some cores disabled, even though it is a dual chiplet 12-core part. You know, to have 4 more cores running at a higher turbo, because the 3900X is 4.6 gigahertz and the 3950X is 4.7, does have a lower base clock, which we've seen. These scale down to lower base clocks the higher the core count goes. Threadripper's the same way. And
that's simply dealing with the physics of the heat being generated by the cores.
Yeah.
I mean, so it would be nice if we could keep all the cores running at the same clock speed.
Yes. And, with really good cooling, then I don't think that these are the lowest Geekbench numbers or the highest Geekbench numbers you would see for this processor. If you can consistently get it, and they offer some overclocking, the precision boost overclocking. I know that Robert Halleck was talking about up to plus 200 megahertz speeds on these, and they were doing some fun things while we were there, like dinner the first night they had a 3950X like off to the side. You had people overclocking, professional overclockers on LN2, getting it over 5 gigahertz. So it's, with exotic cooling, yes, you could overclock a lot, but I'm sure they're reaching about as far as they possibly can to get that 4.7 turbo. And I'm not sure exactly how their turbo works. And Halleck was trying to sort of explain it in response to somebody on Twitter. He said, it's not like Intel. It's basically you only have a limit of power delivery to the CPU, temperatures, voltage, to potentially hit higher boost clocks on more cores, where Intel, like the 9900K, is up to 5 gigahertz on the first 2 cores, and then it drops until you're at like 4.5 to 4.7 on the last cores. And that new product they tease is kind of the same situation as Ryzen 9 90 or 3950X, which is the i9 9900KS. And that is the product they teased as 5 gigahertz on all cores all the time, but it's not available yet. And the speculation is that it's going to take them a while, even with automatic binning, to find enough parts to release this with that extremely aggressive target.
I think everybody listening understands binning, but for anybody out there who doesn't, the idea is that they test processors, there's the fab, the chips are manufactured, they're put in the case, you have a thing, you drop it in a test bed, and the test bed basically throttles it up to see how stable it holds at higher frequencies. And bin sorting is like, oh, this chip runs really, really well at, base frequency, and it runs okay at base frequency plus, so we can sell it as base frequency plus. This one, wow, it's like twice as good as that one, so that's going to be a premium processor. That's grossly oversimplified. But the idea here is that literally, let's say 1 in every 100, 1 in every 2,000, 1 in every 8, we have no idea what the actual number is, of the processors they will produce will scale up to run all cores at 5 gigahertz. Why is that? Super magic pixie dust. Something happens in the process where that one, has a particular combination of features that allows it to operate at higher temperatures in a stable manner. So that goes off the side door and gets the special box and the incredibly high price tag. When to go back to AMD's tweet, it seemed like to oversimplify what they're doing, again, because that seems to be my theme today. They are trying to run everything at the highest possible speed, and the way their monitoring works, because they have sensors all over the chip, they can constantly adjust things to try to figure out where they can max out performance and where they can push things farther. So it's not like, okay, we got this core and it'll go this fast. Well, we got these 2 cores and they'll go this fast. They're like, man, let's just, they have the equivalent of a whole bunch of engineers running around twiddling knobs, trying to figure out where they can maximize performance, on every single parameter of the chip, which is a radically different architectural decision and a radically different way of handling processor loads than what Intel has done. And they've been tweaking it, over the last couple of years. We saw some modest advantages with the 2nd generation Ryzen, and now we're looking to see some really serious gains. As we like to say here, we can't wait till it ships and we can test it ourselves. It's a really interesting. Go ahead.
I was just going to say, I was going to jump in, and just for anybody who also doesn't know what chiplets are, or would like an explanation of that. So we're just talking about binning, which is literally just sorting and testing and more sorting. But the chiplet design that AMD is using, and the reason they were able to go up to 16 cores to begin with, they're coming off with these CPU dies, and they're manufacturing those at 7 nanometers. That's been their big push. There's 7 in everything. There's 7 in the release date of 7.7. And there was the Radeon 7, which is the first 7 nanometer GPU. So they make these CPU dies at 7 nanometers, and those wafers come off and they do their binning. And then they make an I/O die, which is literally input-output. It handles most of the functions that your processor needs to handle in relation to your motherboard, your peripherals, your expansion cards, storage, and that sort of thing. So that is on this package as well. That's manufactured at a different process. And actually, all along, they had been telling us that they were manufacturing this I/O die at 14 nanometers. We found out at our tech day that that's actually only 12 nanometers. And so it's a 12 nanometer I/O die, a 7 nanometer CPU die. And when they initially announced this at CES, it was just one of these little CPU chiplets, they're calling them, just because they're very small CPU dies, and it's a modular approach to making processors, where you could put more than one chiplet on this package if you wanted to, or if you had space for it. So there was a lot of conjecture about them adding another one, and sure enough, there was space for it. And so this new 3950X is 2 of those 8-core 7 nanometer processors side by side on the same package, nestled on top of this larger 12 nanometer I/O die. So that's the whole idea behind this approach, is being able to have the flexibility of taking these CPU cores, like these dies, that each of these dies can contain up to 8 active cores, and then assemble a CPU after the fact, after the lithography, after the process of making the CPU die is all done, and then decide, do I want to put 1, 2, or in the case of those EPYC server processors, which are on a much larger package, up to 4. So in theory, you could stretch this same modular approach out all the way up, scale it up to a 64-core processor, or a 32-core 64-thread processor, probably, in reality. So there's
I'm
a lot
down
of
with
room.
that. I probably don't want to pay for it.
Yeah, I mean, on the server side, there are higher core counts with Epic, which is their server processor line, and there will with Zen 2 and Ryzen. But it's really interesting because they've done the work. They've gotten to this point. They have 7 nanometer going with TSMC is the name of their fab that they're working with. They don't have their own fab like Intel. And Intel is rather famous at this point for their struggles with their own fab. They don't outsource their CPU work. They do all the design and manufacturing in-house. And that's why it has been a struggle for them to get off of 14 nanometer and get going on 10 nanometer and get the performance that they want, get the power consumption that they want. So,
well, I mean, for years, Intel was ahead of everyone else in terms of their process, their fab. And it's only in this last jump from 14 meter to, God help us, anything other than 14 nanometer where they've hit a wall at rather high speed and rather publicly. So they're, whether that's because they diverted their internal engineering focus or getting to 10 or 7 nanometers is much harder than anybody thought, or they make some wrong engineering decisions at some point. They have certainly been struggling with that. They still make money hand over fist. I was talking to that about a friend of mine because, yes, AMD is crushing it on desktops. We're very, very curious to see what their next generation of mobile parts looks like. They've certainly scored some wins from some very major vendors in the laptop world. But the vast majority of CPUs being sold these days are not desktop, they're in laptops. Right. So I want to say, there was something crazy like $37 billion of Intel's revenue last year came from personal computing or desktop and mobile computing out of the 70 billion they made last year, a significantly large chunk of it. So it's not like they're hurting, although they are hurting based on the reports we're hearing from vendors, and the simple fact that AMD is was slowly catching up and looks right now as if they are leaping ahead in terms of system performance. Or if you want to go to sort of, IOPS per dollar, I did the math, right? The flagship Intel CPU is looking like 1.6 times as expensive, or, the Ryzen flagship is going to be 62% less money. Either way, if these benchmark numbers are legit, and remember, these aren't final numbers, these aren't shipping parts, but if these benchmark numbers are legit and they can actually make enough of them to fill a demand, this is a no-brainer for a lot of people that have challenging computing tasks, whether it's rendering video or editing audio or dealing with massive databases, or if you're compiling huge amounts of code. Anybody that has a project that they need to throw cores at, this is looking like, if it works, this is the bargain. This is maybe an even bigger bargain than the 1800X was when it came out, and the 1800X was a massive bargain when it was released. So, yeah, I'm excited.
And we're seeing huge increases in core counts, faster clocks for sure, but they haven't really raised prices at all. If you look at that first Ryzen launch into Ryzen 2, and now the 3000 series. You're still looking at Ryzen 5s at $199. You're looking at Ryzen 7 starting at $329, which the Ryzen 7 3700X at $329 is exactly where the Ryzen 2700X currently sits, although it frequently sells for less. In fact, it's currently $279 on Amazon the last time I checked, which, is in preparation for these new parts coming out. But to have the same list price for a part that has higher clocks, you're at 8 cores, 16 threads. Now you have a 12 core, 24 thread part. Ryzen is 2700X, 6 cores, 12 threads, or was that? Because I think Ryzen 5 was 4 cores, 8 threads before, and everything moved up. I could be completely wrong. I should look this stuff up, but Intel has obviously, Intel has obviously felt the pressure from Ryzen since the beginning, because look at what they did from 7th to 8th generation. 7th generation, they still had dual core i3s with hyper-threading or not. Then they had Core i5s that were non-hyper-threaded 4-core parts, so just 4 cores, 4 threads. Core i7 was how you got your 4 cores with SMT or hyper-threading, so your virtual additional threads, your additional cores. And then the Core i9 was sort of a response to Ryzen, along with, in the 8th generation, raising core counts. So now Core i5 processors, even the cheapest Core i5 processor, and there is one you can buy for $149, like the 9400, I think, that comes without graphics. That is a 6-core, 6-thread part. So that's a huge win for anybody on an Intel platform who could use that CPU, because that's very inexpensive for a 6-core part with decent clock speeds. But that would not have occurred, I'm sure, for a while yet, unless they were forced.
Right.
How is it you go from 4 cores with Gen 7 to everything with the same branding is now 6 cores, and now the Core i3 parts are all quad core? So even the lowly Core i3 8100 is a quad core part, just like the previous generation's Core i5 had been, but it sells for a lot less money.
Well, this is also this comes into marketing and brand segmentation and a staggering lack of competition that Intel had for a number of years. AMD Ryzen 7 1800X comes out, I want to say 2 years ago now, 8 cores, 3.6 gigahertz, 4 gigahertz turbo. The 2700X is 8 cores, 16 threads, max boost clock of 4.3 gigahertz, base clock of 3.7 gigahertz. And they've just been turning the screws on Intel, and Intel's only response is and it's a good response for Intel, is to, accept the fact that they have been working very, very hard to create lots and lots of segments at lots and lots of prices that preserve this massive, or you could argue perfectly agreeable and fair, and under the we live in a capitalist world. They're going to charge what the market will bear. They're trying to keep their margins high because they don't want to go out of business, because they are a company. Their highest goal is to maximize value for the shareholders, and they've done a really, really good job of having, like, I want to say 25% margins, maybe more. So the kind of margins that any television company in the world, television companies would kill for 5% margin on an LCD flat panel. So I love the fact Intel had no challengers for a long time. AMD kind of came out of nowhere. AMD's got I think Dr. Su put down a really intense plan. And is, if this thing ships in September and it ships in volume, man, I'm going to be super excited. As soon as pre-orders go up, I'm in. I'm already looking for a way to stuff this into my micro ATX case, mini ITX case, to figure out some way to cool it with an entirely too small cooling system. But we all need to have goals. The other thing that came out, by the way, it wasn't all just obscure processors that don't exist yet showing up on benchmark sites. You were at the event for the 5700 and the 5700 XT. Did they live up to our predictions, sir?
Well, the most interesting thing to me about them, and it gets kind of murky if we start talking about architecture, like the actual nuts and bolts of how the graphics subsystem works. But a lot of what we were doing at the event I was just attending was learning about the new architecture, and that was the big point, was that this is a new architecture. So for the last 7 years, AMD has been using something called Graphics Core Next as the graphics architecture for all of their GPUs. So GCN is the abbreviation. Graphics Core Next is in workstation GPUs. It's in all of their Radeon products. And it's 12 years old at this point. It was introduced with those 7000 series cards. I believe it was the 7970 was the initial GCN architecture card. So that back in 2012. And so it has shown its age. They've done as much as they could with it. They've refined it. They've reduced latency. They've done what they can. And the ultimate expression of what you could do with GCN was the Radeon 7 for gaming, which obviously by coupling it with an extra 2 channels of high bandwidth memory, they took the memory bandwidth to just ridiculous levels, 1 terabyte per second of throughput. And yet the core, the GCN core, was still limited to a total of 64 compute units for a total of 4,096 streaming processors. So without further refining or improving the architecture within the limits of 64 CUs, you were kind of stuck. And they got additional clock speed out of it by focusing more on that than on power savings with Radeon 7. So it was still a 300 watt part, but with the same 64 CUs as Vega 64, far better performance. It's not even close. At the same wattage, a Radeon 7 wipes the floor with a Vega 64. So that being said, GCN, which was basically built for high bandwidth memory, at least in this last few generations of it, Navi is different. Navi is not based on high bandwidth memory. It's based on regular GDDR memory. So GDDR6 is what this was built for. They're using fast GDDR6, the equivalent speed, 14 gigabit per second speed that NVIDIA uses for the GTX or the RTX 2080, 26 or 2070. And that means with a 256-bit wide memory bus, they are getting 448 gigabytes per second of memory bandwidth, which is basically what that first HBM product that they had on the graphics core next architecture could do. I think it was the Radeon Fury X. So GDDR memory is finally fast enough that they're getting that sort of original dream of ultra high bandwidth memory without having to build a platform for HBM, which is more expensive. So these first products that were going to be announced, which was the 5000 series or 5700 series family of GPUs, we knew they were going to be on Navi. And what we learned was the architecture internally, and what they were telling us, is actually called RDNA. That's the new architecture. So GCN is out, RDNA is in. There's a bunch of new features, some really interesting stuff coming in the Radeon software that everybody with one of these Navi cards will be able to take advantage of, like, zero performance hit, enhancement to sharpness when you're upscaling, if you're using GPU scaling from a lower resolution to a higher resolution, which is something I'm looking forward to, because I am like a lot of people where if you buy a 4K display, you want a really high resolution display, and you can't really play your game at an acceptable frame rate at 4K with all your high detail settings. You might play at a lower resolution. So they were showing things like that. Like the new Unity engine has this built in where it does this intelligent upscaling with sharpening, and they were kind of making fun of NVIDIA with DLSS by saying, our upscaling technology actually sharpens the image instead of making it look softer. And they were showing like side-by-side comparisons, and there was a lot of snickering. But aside from like software stuff like that, we're talking about an entirely new approach from the bottom up, using what at a high level looks like GCN all over again. And I was like looking over these charts, talking to somebody about this from the very bottom, and how like the instructions are actually processed, the width of the instruction set, like how many clock cycles things take. A lot of things have been doubled. Actual instructions are taking less time, fewer clock cycles to get through. So it's is a very, very efficient architecture from the very bottom. And what we saw with some of the internal benchmarks from this, because AMD was showing a few slides that showed like this new Radeon RX 5700 XT versus a Vega 56, and they're showing, pretty substantial gains, like up to 30% better performance than a 56. So my first thought is, okay, this is a card that if they're showing it versus their own Vega 56, it probably isn't going to beat a Vega 64. Or if it does, it won't beat it by very much. And then they showed the Radeon RX 5700, the non-XT version, and that they were comparing against a RTX 2060 as a 1440p gaming solution. And it was beating in their benchmarks with their settings and their choices of games, which was a good selection of games, including some NVIDIA-friendly titles. And it was consistently beating the RTX 2060. So seeing these numbers and hearing some of the specifications, because these are very highly clocked cards, they're not using the full 64 CUs, if they are even limited to that anymore. This was a 40 CU part, and then a with the 5700 XT, and then with the 5700, I believe it is a 32C CU part. Yeah. So, or 36. So you're at a total of 2,560 streaming processors with the XT and 2,304 streaming processors with the non-XT version. And high clock speeds. Base clock speed on the reference card for the XT is 1,605 megahertz. And clocks on the non-XT card are 1,465. They're introducing a new term, which is confusing for these, the way they handle boost clocks, because we're used to this with both AMD and NVIDIA, and NVIDIA just calls it base and boost, basically. And the boost clock is kind of the beginning with NVIDIA. They do things a little bit differently, and it starts at whatever they list. So if the boost clock is 1,800 megahertz, you can pretty much expect spikes of up to 2 gigahertz or above with their current architecture on the NVIDIA side. And with really good cooling and a very good card and maybe a little bit of an overclock, you can consistently push it 100, 200, maybe more megahertz higher than its advertised boost clock. But what AMD is advertising is a real world game clock, as they're calling it. And AMD's game clock is what you should average while playing real games for extended periods of time. So they are advertising a game clock for the XT of 1,755 megahertz. So that's 150 megahertz above base. And with the Radeon RX 5700, they're advertising a game clock of 1,625. So that's, another, I think it's 160 megahertz above base, if I'm doing my math correctly. So on top of this, they have what's called a boost clock. So that's instantly a bit confusing, because now you're looking at, okay, base, game, and then boost. And boost is more like on the workstation card what they would call peak. And with Radeon 7, they had a peak clock, like the workstation cards. And now they're calling that boost. So we were kind of all staring while we were having this explained to us. I'm personally on board with them calling it a base clock, a boost clock, and then a peak clock, like with Radeon 7. Right. But they want to brand it a game clock, and you could see speeds of up to 1,905 megahertz out of a 5700 XT reference card without doing anything under shorter workloads. So shorter benchmarks absolutely will be running at that high speed. So you might have some artificially high benchmark numbers. But for longer workloads, you will start to see the same drops you see with an NVIDIA card, where over time you hit power limits or you hit thermal limits, which is most of the time you'll hit a thermal limit before you really hit a power delivery limit. And that's where you're going to get settled down into your game clock. So the pricing, though, is kind of where these... it was going to be the most interesting part to me. We already knew Navi was going to launch as a mid-range part, because that's what AMD said. That they had the Radeon 7 as a high-end enthusiast part already. That 7 nanometer is a new process for them. They're building a new architecture. They weren't going to come out with the ultra high-end card first on Navi. They were going to start in the middle and then eventually work their way up. And the pricing on these for the 5700 XT, they announced at $449. So for a card that internally they show winning some and losing some against the RTX 2070, which is a list $499 part, you can argue that this is still a good value, because it's $50 below the list price of NVIDIA's part and can trade blows with it. It won't win every game, but especially games that are optimized for Radeon hardware, you can get just as good of an experience. And then they're also trying to showcase the features you get with the Radeon software and some of the enhancements that are coming. Now, to look at the big picture here, AMD versus NVIDIA, NVIDIA at that $500 mark, they're offering hardware ray tracing, which has been a very hot topic, and it's obviously controversial. Do you need ray tracing at all? Are there enough games to justify it? Is NVIDIA charging a premium for a feature that people don't want or need, et cetera, et cetera? And RTX has not been the huge success that I'm sure NVIDIA would have liked, and it was very expensive at launch. If you looked at where the GTX 1080 was when it launched at $499, And then the 2080, you'd expect a faster card, a better card a year or two down the road. And they did that, but the RTX 2080 was significantly more expensive. It was $699. You were getting into that like TI territory from the previous generations.
Right.
And of course, the 2080 Ti is very expensive, well over $1,000. I think it's $1,300 for the Founders Edition. It's either $1,200 or $1,300, and you can find boards that are $1,100. Oh, I see. It's $1,199. Quite a deal. So you can get yourself the fastest single GPU currently for gaming is the 2080 Ti, no doubt, and that is $1,200. So almost double the price.
So that's unobtainium for most people.
Yes.
We're seeing some really impressive stuff in terms of ray tracing being applied to older games, which kind of fits in with one of our pre-show conversations involving remakes of Final Fantasy, which to me on some terrible level, it means like, oh, let's do that whole thing that Hollywood does where they take an old movie and remake it and depress us. Except that in this case, I think remakes of older games confuse me, but, applying modern graphics to classic gameplay bothers me a lot less. We kind of talked that to death last week, but even with a relatively low impact game or a game that could be run on like a tiny percentage of a single core in its original form, once you throw ray tracing at it, becomes something that is hitting barely playable frame rates at 4K. Again, there's a huge ray tracing is it's early adopter. It's early times. It is, if you have the money and a game you like has ray tracing, that's awesome. Unfortunately, where there's an obvious, profound difference between a game from 5 or 10 years ago that's had ray tracing applied to it versus a contemporary game where the differences are much more subtle. I think NVIDIA is trying very, very hard to put themselves out ahead because they know Intel's coming with GPUs in a couple of years. AMD has been catching up in performance. So I think at some level, ray tracing was their effort to take a leap ahead. And if you're watching the video right now, you've got this great, Kevin pulled up this great demo. And this is kind of the ultimate scenario. It's a shiny car. You're next to it. There's an explosion. And look at how amazing the reflection is. And then, whip it back the other way. And this is what it looks like in normal gaming.
It's so dull and uninspiring.
It's dull and uninspiring. But here's the thing. When you're playing a video game, right, and let me make it clear, it's amazing the difference that ray tracing applied to an older game delivers, right? And, of course, it comes with a performance penalty. But when you're playing, most games you're playing with lots of explosions and shiny cool stuff, you're usually running around too fast to enjoy. Now, maybe there's this effect where you're noticing all of this additional detail in the corners, but the reality is that it is early days for RTX to get, awesome 1080p performance. I'm not even going to touch 4K. You'd have a very expensive GPU. You're going to know that you're taking a massive performance hit by turning ray tracing on. There aren't a lot of games that built it in. I'm very curious to see what ray tracing looks like after it is, games have been built into it with the ground up, or maybe when we get into stuff that's maybe slower, more turn-based, something like, or something like Myst, where you just kind of wander around and look at all of the amazing things and poke
or
and try to,
Yeah, like the Crytek, like you're talking about adding it to the game engine, so it's
right.
Part of it from the ground up. Like Crytek with their Cry engine, they had that Neon Noir demo. A game like that, a Blade Runner style game where you're walking around a city, something like Cyberpunk 2077, where that's a different example. That's more of an FPS, but
right.
A game like you're talking about, like Myst, if you're exploring an area where you'd see a difference. There'd be a different level of immersion with that kind of lighting and those kinds of reflections, like reflections off of water, and that would be great. And we've already seen, like, that Neon Noir demo from CryEngine that was rendered at 30 frames a second, but it was still rendered on a Vega 56, not even a Vega 64 or a Radeon 7. So
right.
With a fast video card, it is actually possible to do DXR stuff. You don't need an NVIDIA card necessarily. They have the dedicated ray tracing cores. But it's going to take time. But I think what happened was NVIDIA jumped on the bandwagon and showed we have specialized hardware that can do this now. And here's a couple of titles that are coming out that'll take advantage of it. And then over time, a couple more came out. But then they had to make a concession. Whatever you say about DLSS, if you look at DLSS versus real-time ray tracing, there's a concession being made there. Yes, you get a performance benefit, but then you get a reduction in fidelity. And then the question is the reduction in fidelity visible enough when you're playing a fast-paced game? Isn't the faster frame rate more important? And we could talk about DLSS and the performance of ray tracing, but you had alluded to the same thing we talked about last week, was you take a game like Quake 2, which had already had a path tracing version created to run on Vulkan. It was a project. Somebody spent a considerable amount of their own time for free making this. You could download the old Quake shareware, like the shareware levels, and apply this, and it was amazing looking. And now we have the Quake 2 RTX version, which is something you can go download on Steam right now. The first 3 levels are free. It's like a $5 game. And that looks absolutely phenomenal, but still a massive performance penalty to run real-time ray tracing with that.
Yeah.
Where, by reviewers online, we're talking about getting 20 to 30 frames per second at 4K. So clearly a game that you're going to run at a lower resolution, like any real-time ray tracing game, you're going to want to run it at 2560 by 1440 or at 1080 to get those really good frame rates. And it's just not there yet. AMD's approach to ray tracing, by the way, and we were talking about the RTX 5700 series GPUs, obviously. Mm-hmm. Their approach to ray tracing is, we don't think it's time yet, basically. They said that in the future, there will be ray tracing on Radeon hardware, but they're kind of thinking that leveraging the cloud is where they should do it, because you have a neural network and a lot of work has to be done to get a game ready for DLSS on NVIDIA's side. They have to have the game supported by NVIDIA to have DLSS enabled for your Radeon or for your NVIDIA card. And with AMD, they're talking about using the cloud to do that work and eventually offering it, but as more of like a cloud/software service instead of actually having to buy dedicated hardware for it. But one other thing that I should mention before we stop talking about these new Radeon cards, there was a third card that was shown on stage during the E3 event, and it's a 5700 XT, but it was the black edition, or they were calling it the anniversary edition. It's a black card with gold trim, and it's $50 more, so it's $499. What's different about it, besides its appearance, is that it is clocked a lot higher. They've binned these apparently, and like we were talking about with the CPUs, this one hits higher clocks and therefore obviously gives you higher performance. And now you're right at that $499 level. So if you're comparing this directly to an RTX 2070 at $499, this becomes a lot more interesting in like a head-to-head comparison because of those aggressive clocks. Whether or not you could hit those clocks overclocking a non-anniversary edition version of this card, we don't know. Certainly not without exceeding the TDP. So just another interesting thing. They had a couple of new things to show on stage at E3. We already knew about the new video cards. We didn't know the exact model names or how much they would cost. But this anniversary edition was a surprise to me. And I don't know how you feel, Patrick, about pricing, but I was really hoping, with all the lead up to this and the fact that these were going to be kind of mid-range cards, that we were going to be talking about sub $400 cards. And the 5700 is $379, granted, but even at $349, I remember the two of us talking about the RTX 2060 launch just after CES. When I got back, we had a show. That card launched at $349, and I was saying, kind of feels like where the performance should be, because this is basically the replacement for the 70, but it wasn't really exciting because it's like, well, they priced it as high as they could and justified it with the performance being just high enough for the price. But you want faster and cheaper.
And you get RTX. Don't forget ray tracing.
I know,
ray
but
tracing.
You can't really run ray tracing on a 2060. You have to use DLSS.
Sure you can. It's 720p-ish.
Hey, you know what? I will say, without being snarky, Real-time ray tracing at 640 by 480 is phenomenal. And, you know, you can do that on anything. But, you know, if you want to play at above SVGA resolutions for things, like if you want to go 800 by 600 or maybe even XGA, you could potentially run XGA, like 1024 by 768. And that would look pretty good too.
I think at this point, if you're listening or watching, you've probably picked up that we are less than enthralled with the state of RTX, viz. The cost versus the benefits, and we eagerly await developments in this field that will make us all excited and happy about it. In the meantime, you know, buy whatever card you can get, and AMD, feel free to drop down the prices on the 5700.
Yes, because not to belabor this point even more, but NVIDIA justified higher prices by saying you were getting special hardware, you were getting something more. You could use an RTX card as a standard GPU, but you also had these RT cores. But AMD is kind of following along in their footsteps and charging the same kinds of premiums. Like the Radeon 7 comes out, it's about as fast as a GTX 2080, kind of. It's a little below overall. But they also wanted $699 for it. And while NVIDIA is saying, well, we also have, you know, these RT cores and we have this added functionality, AMD was saying, but ours is also a really great creative product too. But creative aside, and that's great. And 16 gigabytes of 1 terabyte per second memory is unbelievable. Find a great purpose for it and you will be very happy. But forget about that. We're just talking about gaming. I don't care about them making their margins. I don't care about them increasing their stock price or answering to shareholders and making their money. I care about gaming performance at the lowest price possible. So if these new cards are coming out at $449 and $379, and they're just a little bit better than NVIDIA's products at $349 and $499, then it's less compelling to me than it would have been if AMD came out and said, look, NVIDIA's charging you all this extra money for RTX, and games don't even use it yet. We don't even have it, and we're not going to. But here's our cheaper cards that play games that people actually play without ray tracing, just as well, if not better, for less money. And instead, they're coming out and charging very close to the same premiums for something that they don't have a hardware answer for what NVIDIA has. So if you're still on NVIDIA's side and are interested in ray tracing and want an RTX card, they still have that advantage. We haven't even gotten into the rumors about what NVIDIA might have in answer to this, which just very briefly is like a product stack adjustment. Like the high end gets higher, everything else gets cheaper, you know, the usual trickle down. And if that happens, then AMD's going to have to drop these prices. But I just looked at $449 and thought, this should have been $399. But they make that extra $50, which, as somebody who doesn't own shares, not only in AMD, but I don't own any stock in anything, which is probably a bad choice at this point in my life for my future. But without having any stocks in anything and not caring about dividends and returns and margins and market share and just wanting price performance, AMD for so long has been the price performance leader.
Right.
Where maybe, like the RX, think about the RX 500 series cards. You can buy a 580 for around $200, $250, somewhere in between those two numbers, and get absolutely fantastic gaming performance. And you can find the cards on sale. You can get the 4 gigabyte versions of like the 570, which is still a very good card. If you're playing at 1080, you don't even need more than 4 gigabytes of memory. One of those for like 179, 189 is phenomenal. And it did really, really well if you look at recent reviews that I've done on like the GTX 16 series cards. Like the 1650 was obliterated by an RX 574 gigabyte. So if you don't mind the added power and you don't mind the added heat, they are just tremendous cards. And these new cards, go ahead.
No, I was going to say, now you've got me frustrated because I'm looking at the 5700 performance chart that AMD put together, and you know it's actually not bad. It's 6% faster, it's 12% faster, it's 23%. You know, Forza Horizon 4, 123% or 23% faster at ultra settings. This is all 1440p. Battlefield 5, 21% faster at ultra settings, but you're mostly looking at like 6, 7, 5, 12, 12, 12, 9%. let's be cruel and call it, a 10. Let's be generous and call it a 10 or a 12% performance advantage. You're right. If all NVIDIA has to do is knock some price off their existing cards, which is to say, all NVIDIA has to do is price the cards where everybody thought they should have been when they were released,
right?
Assuming they have margin in there, and then AMD is going to have to cut to match. And it almost feels like AMD is following NVIDIA's pricing structure at this point. Charge as much as we can, and especially if they have limited availability on parts, which has kind of been an AMD tradition when launching GPUs in the last year or two. Last year, let's not count the year before that when you couldn't buy a GPU for love or money. But when you look at this, it feels like, unlike where they're going with Ryzen, where they're taking huge strides ahead in terms of GPUs, it's like, okay, we're there, and okay, we're there, and they dropped the price. So then we're going to have to, I feel like I'm wondering if there's going to be sort of a generational leap, between this generation of AMD graphics and the next generation. In any case, it would have been, you've got me totally on this whole, like, they should have given you more or charged less for it.
Yeah, but they, as a company, are doing really well. I'm actually looking at their stock price right now. It's kind of the opposite of what we've seen from NVIDIA, where NVIDIA took quite a tumble from the very lofty heights they had a couple of years ago when crypto mining was going absolutely crazy. Just since the beginning of this year, I'm looking like January 2nd, AMD stock price was $18. Actually, on January 3rd, it was only 17.
Right.
And as of June 10, it was at 33. Their market share has gone up. Their market cap has gone way up. They're worth a lot more money. They're doing so well. Lisa Su is becoming like the CEO of the decade all of a sudden and turned this company around. And we've heard all these amazing things about how well she has done with AMD. And it's almost like the company is changing a little bit. If they become a leader, then I think some of the people who always thought of them as this lovable underdog that, maybe they didn't have the fastest, but they did compete on price and they were cheaper. You could buy a much less expensive CPU from them than Intel, and you could buy a cheaper GPU from them than NVIDIA and get good performance. And they have developed this sort of cult-like following in certain parts of the internet where there are people who are really, really strong, like Team Red supporters. And if they end up becoming just another big, successful company with a comfortable lead in performance, then we're not going to see those aggressive prices that we used to see. What reason would they have for that? If their investors are happy, if the board is happy, and they're making money, and their stock price keeps rising, why would they change? And I just want to see what NVIDIA does in response to this and see how they answer as far as pricing goes, because NVIDIA set this bar of a high-end graphics card now costs $700. Not the highest, but just high-end. Like, if you're an enthusiast and you really care about gaming and you want to game at high resolutions, if you want to game on NVIDIA, you need an RTX 2080. And if you have the money, a 2080 Ti. If you want to game on AMD, you get a Radeon 7. And those are $700 cards. And I would love it if, it's sad to say, I would love it if they were $500, because that's still $500. But, the GTX 1080 was $500. And that was an amazing card for $499 because of what it could do compared to previous generations. The gains they got were just huge. And, we've been waiting all this time. AMD fans have been waiting since the RX 480 for Navi. And Navi was on the roadmap. We heard about Navi. It was going to be the savior. It was going to bring AMD back to the promised land, and Radeon was going to win again. And, here we are a couple years later, and we've had the refresh. It went from RX 400 to 500 series, and basically higher clocks. They worked on the process. And then this last fall, when the RTX cards come out, the only real answer from AMD is, well, here's a higher clocked RX 580. It's called the RX 590. And that thing, takes a lot of power. It is faster than a 580, but it's really just an overclocked 580. And now we've waited another, 8-9 months and we have Navi coming out. It won't quite be a year between the 590 and Navi, but when these 5700 cards come out, they are new architecture, faster, some exciting new features, but you're paying for it. It's not like $199 to $249. I've seen the RX.
Oh, you're always going to pay for it.
Yeah, it's double. It's double. I've seen the RX 590 sell for around $220, and now we're talking $450 for that big jump that we wanted.
Let's turn this boat. Let's steer this ship in another direction.
And about time too. Sorry.
This horse is the horse is now beaten flat and appropriate for use as a writing paper substitute. Xbox Project Scarlett, everything we know about Microsoft's next console arriving. Well, The Verge put this one together. It's a really nice summary of all the stories they've done pretty much since June 10th, 2018, right? New Xbox consoles and the game streaming service, and it goes on and on and on. And it culminates in an interview earlier this week. Xboss Phil Spencer on the future of gaming. The business isn't how many consoles you sell. And, or the actual quote the Andrew Webster was given is, I don't need to sell any specific version of the console in order for us to reach our business goals. And so this is, this is interesting, and part of the reason that Mr. Webster has an interesting conversation with Phil Spencer is, this console isn't going to exist until 2020, fall of 2020. So it's over a year out. They're going to have Halo Infinite is going to launch with it. They're claiming 8K support, SSD storage, finally, and ray tracing graphics. Oh boy. They're also claiming it'll support existing Xbox One game controllers and accessories, which if you have a giant pile invested in Xbox One, this has to be a welcome thing to hear. They are going to keep the optical disk drive, which I think is fantastic. And, quote, support 4 generations of Xbox games through backwards compatibility, which is pretty epic. So rumors say that there's going to be 2 next-gen Xbox consoles. Microsoft is only talking about Project Scarlett for now, writes the editors over at The Verge. And this is really early. There's questions about whether or not the Xbox One was the most powerful console ever, and now, just a couple of years later, you're releasing it or announcing, right, a new console. I'm really kind of curious, and it's really kind of vague, right? Because Mr. Webster asks, is Scarlett one console, or is it like the Xbox One where you have a high-end, a middle class, and a cheaper one? And Mr. Spencer's response is, the video that we showed is talking about Project Scarlett. That's the focus that we have on that console and hitting that specification. That's the console we're talking about. And
it's a great non-answer, but it still kind of answers the question. Yes, there will be more than one console. This is Microsoft we're talking about. We've seen what they've done with the Xbox. They have the Xbox One. There's the Xbox One S. Yeah, they'll segment it. There will be the mainstream and the enthusiasts, just like there's PS4 and PS4 Pro now.
Yeah, and I mean, he comes back, like Mr. Webster is like, if the Xbox One is the most powerful console, then 2 years later there's a new, more powerful console. Doesn't that diminish what that means? And it's a funny thing, because there was a running joke that Ryan and I had a couple years ago, where every 17 days it seemed like there was a new fastest GPU ever. It was just this weird cycle where for 2 or 3 months, somebody was coming up with the fastest GPU ever, and Spencer's point, he says the business isn't how many consoles you sell. The business is how many players are playing the games that they buy, how they play. So if somebody bought an original Xbox One from us on launch day and they're buying and playing games, I don't need to sell them an S. I don't need to sell them an X. If they want to play on the Xbox One, they have and stay as a great member of our community or subscribe to Game Pass. That's a great business for us. I think it's easy from the outside to judge the health of our business around how many consoles the company sells. In the end, how many subscribers you have to something like Game Pass, how many games people are buying. Those are much better metrics on the health of the business.
And much bigger drivers of profit, Patrick, because that's what it's really all about. We're talking about Microsoft, who made their billions selling software licenses. So it's not like, and they've dabbled in hardware obviously in the past a lot, and this is a great example of, we'd love you to be on one of our platforms because then you will pay us for this service and we get a nice cut of every game sold, physical or digital. So yeah, they're fine with you playing on whatever you can find. Just log into an account, pay them the monthly fee, and they're happy.
Well, as well they would be. I'm curious, right? Because they're talking about integrating cloud streaming into this. They're talking about Project Azure, which of course is cloud streaming. I thought it was interesting for him to flat out say, like, buy it, don't buy it, just freaking subscribe, just play the games. And because
in other words, we're not making margin on this, so please you don't have to buy it because we'll lose money if you do. But subscribe to our service because that's where we get our margins.
Yeah. And that that's alarmingly close to being honest because there's I'm just going to call it a pissing. There's been a pissing contest between Sony and Microsoft over console sales for a long time, and the reality is they're giving away razors to sell blades. I'm very, very curious to see what this ends up looking like and what they end up. How about what they end up losing on it to deliver 8K performance because. Again, they're talking about ray tracing, talking about 8K, they're talking about 120 hertz, not necessarily at the same time, but 4K, 120 hertz. The possibility, I could care less about 8K, but 4K at 120 hertz is really interesting. Zen 2, Navi, this is going to be a pretty powerful box, and I suspect it'll come with a pretty awe-inspiring price. So,
and from what they've said, it's been very vague, but from what they've said, it's kind of mirroring what Sony has come out and talked about, where they're going to have solid state storage. They are going to be on the Zen 2 architecture for CPU. They're going to be on RDNA. They're calling it now instead of Navi for the GPU side. But, they're not talking about core counts. They're not talking about clock speeds. They're talking about exactly what kind of solid state storage. Is this SATA storage? Is this some sort of really fast M.2? So we'll have to wait and see, obviously, what they ship. But it's still going to be considerably faster. It's funny, though, if these are basically PCs at this point. So for anyone who's complaining about them releasing a new console and then 2 years later having a faster version, a company, a big PC company like Dell or Lenovo, they would die if they only released one new laptop every 2 years. That wouldn't work. You've got to come out with the latest stuff as the hardware advances or you lose relevance. And if they're not going to do it, then Sony will. So they have to stay competitive. And this announcement is basically just a rebuttal to Sony's like, well, we also have something really, really great and really fast coming. We're not sharing any details of it. And here's some really shadowy, like macro photo of the edge of a PCB. But,
Welcome to the PC world, gentle console gamers. Speaking of controlling the narrative and defining the conversation about a new project, not quite so far out as Microsoft is Google. Google has been plagued by rumors and leaks and random pieces of hardware showing up, in the eastern, basically showing up on eBay in Eastern European countries. It was really interesting to watch all the mayhem around the Pixel 3. Google basically is getting out in front of and defining the narrative, if you will, around the Pixel 4 launch. Quote, well, since there seems to be some interest, here you go. Wait till you see what it can do. And it is it's a Twitter post made by Google with the Pixel 4. Not a rumor, an actual picture of actual Pixel 4. There's on the left side, if you can see it, there's a back bump. It's got at least 2 cameras and another sensor inside of there along with the flash. And it's got a G, and I don't think we're seeing the front in either of those pictures, but it is, it's coming. I also was laughing. Marcus Brownlee, I think, was like the first person to respond. Quote, at least let me drop my dream phone 2019 first. Assuming
how are YouTubers and serial leakers and the rest of the world who follows this process of, like you said, not just leaks, not just fan renders, but like the cases that come out, or people start speculating like, well, this is what the dimensions will be, because this one case company said they're pretty certain it's going to have this camera opening,
right,
and it's going to be this thickness, and this is the screen size, and then they debate over whether or not it'll have like a phone, like a camera cut out on the front, and where we saw all of this with the latest Galaxy launch, where there were all these renders out first and speculation about whether it would have a notch or a hole,
right,
and for them to just come right out and show this kind of kills that little cottage industry online of, reports and leaks, and here is a component that I found, and this is the component number, and that's been matched up from one of my sources from the supplier, is this is going to be the camera sensor in the next phone. So we'll still see that kind of stuff, like speculating what the new internals are going to be. But the design, obviously they're showing the design, and it basically looks like what we've already seen, at least reported or rumored to be the next iPhone, where you're going to have a big square bump on the back with a cluster of cameras and sensors and things in it.
Yeah.
So they're ready, apparently. If Apple was going to solve their low light issues with their cameras and get up to Google Pixel level, then Google already has the next, even better camera solution, I'm sure, waiting.
I got to say, I was also kind of in love with Smarter Every Day, which was like, made by Google. It's like Marcus Brownlee, at least let me drop my Dream Phone 2019 video first. Made by Google, the year's not over. Third post, Smarter Every Day, micro SD memory expansion, and a headphone jack. And boy, howdy, will you get me excited. That made me super happy. In fact, I'm going to like that right now.
Wait, has it been confirmed that it does have those things? Or can you see
that was him asking. That was
just asking.
That was his response to the announcement. They're not going to put a micro SD card slot in there. It would be incredibly useful. Just like they didn't
Patrick,
put one.
It's 2019. Why are you still plugging in headphones? Stop being pretentious and acting like you can hear the difference. 256K Bluetooth audio is just fine, okay? And everybody thinks so, except you.
I wasn't even about it. It's just I already own a bunch of nice headphones, and I've got 5 sets of Bluetooth, aptX, or LDAC, wireless headphones in here. Just I like a headphone jack. It has advantages, especially when you're in automotive environments where the automotive Bluetooth may be sketchy and semi-functional. You're just such a hater. Speaking of hating, 5G continues to trickle out. I'll stop.
I was going to point out that headphones still come in handy when you're on an airplane, because for some reason they don't like you to use like a bunch of wireless signals while they're flying around. So they still have a 3.5 millimeter jack on their little infotainment system. And if you didn't remember that, I was literally sitting next to somebody who had a pair of headphones and it had a lightning connector at the end. Like, that doesn't work, dude. It can plug into your iPhone and that's it.
Well, if you're all iPhone all the time and still have a lightning jack, it's pretty functional until something changes, and then you buy new headphones, which is great for the headphone manufacturer. I was about to snark on 5G. AT&T brings Samsung Galaxy S10 5G June 17th, but only for AT&T's developer program and or AT&T business customers. AT&T, quite frankly, is taking its time on its 5G rollout, which I think actually makes sense. They added 7 cities to their list in April for a total of 19 cities in 5G. One of the interesting thing to note about this, that if you're watching the video, you can see a text by Chris Welch, which is one of the writers over at The Verge. And this is kind of amazing, right? Downloaded Iron Man 2 from Prime Video at best quality in 90 seconds. You can see here that Verizon's network occasionally falls back to 4G LTE. He's right across the street from the 5G node. So 5G, when it's doing its 5G thing, is absolutely phenomenal if you move large amounts of data. It's phenomenal for a bunch of other reasons, but we won't get into that at the moment. But the thing is, if you're actually near a millimeter wave 5G hotspot, right, he's across the street from it, it's awesome. But you have to find one. You have to be within range of it. The Verge was getting gigabit download speeds, but you pretty much have to be line of sight with the node for that to work, because the frequency is so high, it gets blocked by, everything in a city. And that's a challenge with 5G. And so, some of these speed claims are going to be very, very difficult to fulfill in a rural environment. And the millimeter wave stuff is fundamentally, unless you have a box in your house that does this, you are not going to get it, or in the restaurant, the diner. So I'm very curious. I don't think a lot of 5G's benefits are going to work quite as well outside of the urban metropolises. That said, speaking of distributing thousands of nodes, Helium, which is a company that started a few years ago with Sean Fanning and a couple other folks, Sean Fanning of Napster phase. They're talking about their cryptocurrency mining Helium hotspots that are going to offer peer-to-peer networking, promising greater coverage than Wi-Fi, as 100, they claim, could cover an entire city. And,
you know what? That's not just hot air, Patrick. It's helium.
That was awful.
Yes,
I
was just, you know what? The whole time you're talking, I'm thinking, I shouldn't say anything about this, but AT&T already promised that we had 5G. I've watched TV commercials on national television broadcasts saying that AT&T has 5G E, and the E just makes it even better. It's one more letter. So why is it they're just now rolling out to test markets in certain very small areas, certain developers?
To their credit, you could look at that as a way of saying, we are going to roll this out slowly, and we are going to manage this, and we are going to try to make it the best possible experience for our customers before we whip open the floodgates in 2020 and start trying to sell everybody a 5G phone. And there are advantages in terms of the basic tower service compared to 4G, in terms of how it multiplexes the data and how it handles users. That'll make for a better experience, especially in crowded environments. But it's interesting to watch. It's also interesting, like Helium's approach is their idea that, Halim, one of the co-founders, is everyday things that we use shouldn't need cellular plans. Which, when you think about that, part of the premise of 5G is, you'll have 5G access on, devices in your house, your car, your cat's collar, your cat's collar's, dog dish. Like, and it's on one hand, it's like, we're going to put this incredible network everywhere, and we're going to make it super functional in low power environments, and all of this cool stuff is going to happen. And all I can think is like, and my phone bill hit $8,000 a month, which is an exaggeration, probably a huge one, slight one. But, as things get more complicated, more expensive on the cell phone side of things, this opens an opportunity for startups to come up with something that is, maybe more affordable, or maybe, figures out a way to take advantage of everyone's, it's going to be an interesting time to watch. I just want to say that, look, 5G, is now starting to work, given that they had sort of a test fest at the beginning of the year where nothing seemed to work, or certainly not at the speeds they were supposed to work at. At least we're now seeing examples of stuff performing at the level it's supposed to perform at, out in the field. This is early days, maybe not so much as RTX.
How much do you think the push for 5G is literally just marketing, like wanting to have that brand and differentiate and say, well, our 5G coverage map is better than their 5G coverage map on commercials? And how think about the fact they we don't have consistently great LTE everywhere in America by any stretch of the imagination.
Right.
Wouldn't it be better to have a world where everywhere you go, you've got 4 or 5 bars and solid, very good download and upload speeds, instead of, we already have situations where you go from one city to the next, depending on who your operator is, you could have 4 or 5 bars and amazing LTE, or you could have 1 bar where it says I'm in LTE right now, but I keep on trying to send this message and it won't upload this one picture, and then you lose the signal entirely. There's no consistency, and already we're talking about 2020 and 5G. It's kind of ludicrous to me, because then there'll be another even smaller fringe area that'll have 5G, but only if you're close enough to an access point, and they're even more directional, like literally line of sight, depending on the technology that's being used. I've joked around about having a drone follow me around, and that's my hotspot, and I always have 5G. But beyond that, how are you always going to have great 5G unless they just put thousands and thousands of little access points everywhere?
Nilay Patel did a really, really brutal and really good article or column. Why the hell is the race to 5G even a race?
Yeah.
And he made some interesting observations, which is one is like, our 4G kind of coverage kind of sucks and the performance is kind of an issue. And this mostly feels like, an argument to make people make poor decisions quickly so the telecoms get what they want and can start getting people to upgrade hardware that won't work particularly well until much later when they finally get everything working the way it's supposed to. The more I hear about the race, Nilay writes, the more I don't buy it. I think the race framing is there to make some big decisions seem urgent and important to make it appear as though some serious trade-offs are worth it in order to win. And those trade-offs are indeed serious. 5G networks will require a serious rethinking of how we use wireless spectrum. There are incredible privacy implications around putting millions of Internet of Things devices in a smart city on 5G. Investment dollars will naturally flow towards building 5G networks in cities instead of expanding our networks to rural areas, exacerbating the digital divide. And, some of the 5G spectrum seems to be interfering with weather sensors, which is of concern to, amongst other people, NASA, the Navy, and the NOAA. The response, he writes, from the wireless industry was a, quote, blog post accusing meteorologists from across 3 government agencies of risking our 5G leadership. So, dealing with storm and tornado detection and making sure, Navy ships don't have issues and our it boggles the mind even by the somewhat greedy and self-centered stance of telecoms to see something like that. I don't know. It's curious. It's curious to look at. It's something, I think you're right. It is, there are some interesting technical ideas. There are some things that will improve performance. The reality is they could also do a better job building out the network and building it out in more places, much more.
There's
so.
A novel thought.
Yeah, but it's much more attractive to the shareholders to build out an expensive network that will require everyone to build or buy new hardware. More money being made, which is, kind of a lifestyle choice. We probably should wrap up this episode of This Week in Computer Hardware because there will be more news coming next week. And some of it will probably not be as snarky, except maybe where telecoms are concerned, but that's a tradition. If you're not familiar with the podcast, you should head over to twit.tv/TWiCH. That's where This Week in Computer Hardware is hosted. You can get information on how to subscribe to the video or audio on just about any platform on the planet, or just search for This Week in Computer Hardware on your favorite podcatcher. You'll find us there, I'm pretty sure. If you want to get more of Sebastian Peek's writing, I highly suggest you go over to pcper.com, a delightful website filled with outstanding writing. And I suspect a whole bunch of benchmarks of AMD GPUs and Ryzen processors in the none too distant future. And if you want more of me, I no longer do Techzilla. That show has sunsetted. It is gone. But you can catch me here at This Week in Computer Hardware or avxl.com or the soon-to-be-launched patricknorton.com. It's a rumor, and it's true. Do yourself a favor. If you haven't subscribed, go to twit.tv/twitch and get a link or search for This Week in Computer Hardware on your favorite podcatcher. With that, ladies and gentlemen, I'm Patrick Norton.
And I'm Sebastian Peek.
Catch you next week on Twitch.